Hi, in this video, we're going to take a look at systems of equations. We're going to learn why you might use them, what they are, and also how you can solve them graphically. So what we're going to do is we're going to start by looking at this situation here. I have, let's just say I want to buy these super cool I Love Math t-shirts, and I want to buy a bunch of them. So what I'm going to do is I'm going to ask Company A and Company B for a quote to see which one is the better buy for me. So company A gives me a quote and they tell me that they're going to charge me $5 per t-shirt, but they're also going to charge me a $50 setup fee. And company B, they're just going to charge me $10 per t-shirt. They will not charge me a setup fee. And you know from previous work that you can represent each of these situations with a linear equation. So let's define our variables before we write our equation. So let's just say that y equals the cost to buy the t-shirts, and X will be the number of t-shirts we purchase. So at company A, the cost will be $5 times the number of t-shirts plus a $50 setup fee. At company B, the cost will be $10 times the number of t-shirts. Now, I want to take a look at these and I want to think about certain things. I want to know when each company is cheaper, and I might also want to know when the cost would be the same at both companies. So to do this, I'm going to take my equations and I'm going to graph them. I'll use the Desmos graphing calculator to do that. So I'm going to pop on over here to Desmos and I'm going to look at my equations. So the company A is represented with the red equation, red line, and company B is represented by the blue line. So you'll notice when you look at the graph that the blue line is lower and the number of t-shirts is on the x-axis and the number or the cost in dollars to purchase the t-shirts is on the y-axis. So in the beginning, somewhere between like 0 and maybe like 9 or 10 or here, company B, the blue one, is lower. So the cost is lower for purchasing at that company. But eventually, the graphs cross and company A, the red line, becomes the lower cost. Now this point right here, where they intersect, is actually the solution to the system of equations. That's the point we're looking for. That's the really important one when you're solving a system of equations. So in this case, the solution is the point, it's the point where that falls on both lines. And in this case, it is 10, 100. So let's pop on back here to our Jamboard and think about what that means, 10, 100. Okay, so 10, 100 is the point that falls on both lines. It's the point where they intersect. And let's think about what it means in terms of our situation. So 10 is our x value because our ordered pair is x, y. So that means that 10 t-shirts cost $100. So when I buy 10 t-shirts, I will pay $100 at company A, and I would also pay $100 at company B. That is the solution to the system of equations. I can also check this out by substituting in the 10 and the 100 for x and y. So let's see, I'm going to put in 10 for x, 100 for y. Let's see, we have 100 equals 5 times 10 plus 50. So 100 equals 50 plus 50, and that is a true statement. So we know that that point works for that equation. If I substitute in over here, substitute in 100 for y and 10 for x, 10 times 10 is 100. That also checks out. So we have found the solution to the system of equations. So this is my system, the two equations here, and the solution is 10, 100 because it is the point that falls on both lines and it makes both equations true.